Hi, Todd Cooper here, based in San Diego, America's finest city. I want to just spend a few minutes thinking about how to move our standards work in IHE and HL7 devices from being document-centric to model-centric. What does that mean? Why would we do that? And what are we going to do to move that forward? This is actually something we've been talking about for the last few months in 2021. Especially around requirements interoperability, separate topic, but how to model that, how to create UML models that actually become the basis for our specifications. In the middle of that, we had a great presentation by Stefan Schlichting at Unity and some of his colleagues around using MBSE to manage complexity. So I'm going to borrow a few slides with Stefan's permission and kind of give you a glimpse of what it is we're trying to do as part of this joint IHE HL7 Gemini device interoperability project. So consider these things. For the last 20 plus years, and I've been around for a lot of that, IHE's development framework or approach for technical frameworks is rooted in how systems were engineered 20 years ago. It's sadly how they really are mostly still today. It's a document-centric approach. We'll look at that in a coming slide. However, to support the more complex, heterogeneous, that means multi-vendor SES MDI environments, safety critical, IHE processes must align with state-of-the-art medtech product development tools and processes. If we want the medtech industry to be able to utilize the specifications that we all develop together, we should do so in a way that benefits them the most. And we should also recognize that, especially in the health informatics technology industry, but the IT industry, there's different approaches that are kind of have a competing tension. To be sure, model-based systems engineering, systems modeling language are really a key way that complex systems developers, including the medtech industry, are moving forward to address that complexity. However, test-driven development, acceptance test-driven development, behavior-driven development, more agile processes are often used as well and are perfectly fine for those applications. We're talking about the really complex medtech solutions where they are safety critical, very safety critical. I don't need to say anything more about that. But as a result of that, they also need to be regulatory submission ready. Whatever says, yes, I'm conformant to an IHE profile designed for the medtech products, that will have to be part of a regulatory submission. How can we help those who are adopting this? So let me grab a few slides from this webinar that Stefan presented, using model-based systems engineering to master complex development more easily. This was back in March 25th, and we were already talking about this. This is one of his slides, though, where he starts with a simple standalone device. How hard can that be? Well, after 40 years of trying, it's pretty hard. But then you add analytics to that, and then you especially add autonomous medical technology to that. That complexity of systems goes up, and the complexity of having systems of products that are plug and trust, heterogeneous, developed by different vendors. That is a complex challenge to make sure that it is safe, effective, and secure. As you can see, autonomous care is a key element of the Johns Hopkins University Applied Physics Lab Madeira project. That's medical device interoperability reference architecture. So this is totally part of that complexity management. And it's a reality, like I said, for those product developers who are wanting to adopt, prototype, and implement SDC, SDPi, medical device communication standards. Another area is not just technical complexity, but also cost of development. It is huge for medtech vendors. What can we do to help them address this total product, total cost life cycle? Identifying issues early on, not allowing issues to too easily come in, especially when different vendors are developing against the same spec where there may not be complete clarity. That cost differential is orders of magnitude the later it is found and addressed. So how can we do that? How can we address the complexity, safety critical systems, and address the product lifecycle total cost. As I said, IHE, like everybody else, is rooted in how we've developed systems for 20 plus years. Document-centric, document-based. We create Word specifications. We bake them into a PDF and everybody gets it, searches for the shall statements and said, okay, how's that going to work? So how can interpret it a little bit differently? And then we have testing events where people say, wait a second, that's not what it means. Oh yeah, that's exactly what it means. And it's very inefficient, very stressful. And it takes a lot to keep these collections of documents and graphics and databases all coordinated and consistent. Whereas in a model-based source of truth, you have a single source of truth, a single model that captures the entirety of the specification. And then different stakeholders can look at the view of the model that is most important to them. One model, multiple views, one single source of truth. You change something in the model, it automatically updates everywhere. That sounds like a great way to manage complexity. And you can also run simulation against it for completeness checking. You can run different scenarios against it to make sure it's right in the first place. And then you can align it with all of the test and conformity assessment activities. You can get traceability and completeness testing. It's a wonderful thing. Here's a little insight into what MBSE is all about. This is one model, the left side of a V model, where you have requirements management, requirements modeling on the left. We were already looking at that, as I said, requirements interoperability. We were saying, how do we actually craft perhaps a UML model of requirements interoperability, and then using that to be able to achieve multi-standard, multi-specification interoperability for this Gemini SDC SDPi+FHIR project. So MBSE, SysML, requirements modeling, it fits in perfectly. But then can we use SysML and MBSE to craft a functional architecture and a logical architecture model? And then maybe also identify different physical architectures that might be able to lend themselves to that. This would make life much simpler for everybody, to be sure. So to summarize, IHE technical framework development process, after 20 years, time to get better, smarter at it. MBSE SysML hits at the core value propositions for the medtech community in terms of safety critical, regulatory submission ready, managing extreme complexity, being able to ensure quality and things are right and not having issues perpetuate and get found late in time. So those are key value propositions across the total product lifecycle. Interoperable MBSE and SysML is definitely a futures proposition. What do I mean by that? I mean, being able to have a model outside of a tool that then can be imported to different tools, that is something that's on the near horizon, but it's not a reality today. But we can start today, especially with requirements interoperability, doing a SysML requirements modeling effort and be able to then export that to RecEF, which we would then be able to leverage, as we've discussed elsewhere, with how we actually craft our documents. So that's the starting point. Being able to come up with model repositories as IHE technical framework artifacts. As we have said, the Madeira profile that we're starting to work on is going to leverage SDPi profiles. Oh, by the way, SDPi profiles will leverage other profiles and implementation guides. Can we come up with a repository of different models that allow us to have a single computable source of truth for each, and then compose them into a new one for the specification we're working on? That's the goal. MBSE can definitely also lower the cost barrier of entry, making it much simpler to adopt and implement these IHE-based solutions, starting with the development costs at the earliest stages of design. As they said, as Stefan and his crew said, the main function of systems engineering is to facilitate communication. That's what IHE is all about, is communication. So the challenge before us is, how are we going to help medtech developers help our specifications become MBSE SysML aware, or artifacts based on that? It's not going to be all done by the vendor community. They'll help for sure. No single vendor, and there's still research to be done. So can we come up with a catalytic project that will support us being able to achieve this? I think the answer is yes, and I look forward to you joining me and being able to participate in this, in the IHE Gemini device interoperability work. So thank you very much, and stay tuned.